Good morning, friends. We'll discuss about the division operator. Okay. So the division operator, if you want to understand, you should understand what is the cross product and what is the set difference. If you have not gone through those videos, I request you to go through those videos and come back to this video for better understanding. Okay. And one more thing I want to request everyone is that go through all the videos in a sequence for better understanding. And if you really like my videos, please press the like button. And if you want to give any comments, whether it is a positive feedback or a negative feedback, feel free to give the suggestions or positive feedback in the comment section. And subscribe to my channel and share the videos with your friends so that they will also feel happy. Okay, so we will discuss about the division operator. The division operator usually we will denote it either like this or with this notation. Now when we will apply the division operator, we said that we will apply the join operators in when we want to combine the two relations, all these things, because every operator there will be some motivation why we should use. So then why should we use the division operator? The division operator we will use whenever there is a query consists of for all. Is it clear? So now let's take that I have a students of strength 60 in a class, and in a semester they have 6 subjects. Let's take that they are studying second year, 60 students are there, they have some 6 subjects are there. Now I want to know at the end of the semester, I want to ask someone that, or I have a query that in a class of the 60, who are the students who have passed all the subjects? Okay, or who are the students have got S grade in all the subjects? Something for all I want to use means for all the something I want to retrieve some information. Then I will use the division operator. Okay, so I hope you have understood what is the motivation for learning the division operator. If you see that so many times people will ask this for all, so there you should apply the division operator. So for a better understanding, I have taken two relations R and S with some attributes list and some tuples, and I want to apply the division operator between the R and S. So I will apply R division S. Okay. Now what is the attributes you will get in the output? The attributes which are present in the relation R but not in the relation S, those attributes you will need will come. In the relation R you have attributes A and B. In relation S you have attribute A. So what is the attribute which is present in the relation R but not in the relation S is the attribute B. So this is the attribute you will get in the resulting output, okay, or in the output. Now what are the tuples you will get? Sir, you have said what are the attributes you will get. It is okay. But what are the tuples you will get? Now listen one thing. For in the relation S, you have the values 1 and 2 for the attribute A. So now you find where is the values 1 and 2 in the attribute A. Meaning is that for the which value of B, you should have the value 1 and 2. Or I can say that if you see that A1 is having 1 and A1 also should have 2, then only we can consider A1 in the output. If you see that A1 is having all the values, because I want to know that, let's take that these are the list of subjects are there in the class. Okay, in a semester the list of subjects are there. These are the list of students are there. Okay, now I am asking A1 is passed 1. Yeah, A1 is passed the second subject. Now A2 passed the first subject. So these are the students list with their corresponding whether they have passed in which subject or not. Now these are the list of subjects are there. Now A1 is passed the subject 1, A1 is passed the subject 2. So I can say that A1 is passed all the subjects. So A1 will come in the output. Now if you see that A2 passed with the subject 1 but A2 did not pass in the subject 2 because it is not there. Is it clear? If it is not there, I can consider that he has not passed the subject 2. So he will not come in the output. Only A1 will come in the result. So I hope you have understood what is the output you will get if you apply the division operator between these two relations. Now we have discussed what is the output we will get. But internally what will happen? Is it clear? Usually the division operator we will call it as an expression. Is it clear? We have two types, means basically two expressions are there. One is the join and the division. Join, why I am calling it as an expression is, lot of people will say that it is an operator, but it can be called as an expression. Why it is so? That what is the difference between operator and expression is, operator is a single one, whereas an expression is a combination of operators. Like if you see that the join, we need to apply the Cartesian product and selection operator. So two operators I am applying for the result, so I can call it as an expression. Whereas the division also we need to apply these operators, so I can call this as an expression. So to perform the division operator, I need to perform these tasks. So now first we will do the first operation. T1 saying that apply the projection. This is a projection operator. What is the projection operator? The notation for the projection operator is this one, and you will have the set of attributes, or I can call it as an attribute list on a R, where R can be a relation or it can be a relational algebra expression, and it will do the vertical splitting of the relation. Okay, is it clear? So set of attributes you will mention, and those attributes list only will display. So that's why it is having 5. Then you can ask me, sir, what is this one, R minus S? You said attributes list, but it was written R minus S. Anyway, I will discuss what is this R minus S. Here R is the relation. Okay, on a relation R, you are applying the projection operator. Now we will apply, they have indirectly given the attribute list, so we need to find them. First list out what are the attributes which are there in the relation R. This is nothing but R minus S is nothing but attributes which are present in the relation R minus attributes which are present in the relation S. If you see that what are the attributes which are present in the relation R? A and B. What are the attributes which are present in the relation S? A. So if I do A minus B minus means AB minus A, if I apply set difference, I will get the B. Is it clear? So the meaning is that indirectly they are mentioning it as phi of B from the relation R. Okay, means projection operator with an attribute list called B on a relation R. So if you see that, you will get, let me write here, you will get B. What is the output you will get? A1, A2. Then you can ask me, sir, why you got only 2 tuples? In this relation R, you have 3 tuples, A1, A1, A2. But remember one thing, projection operator will always eliminate the duplicate values. A1 is repeated twice, it will only come once. A2 is unique, so it will come. Okay, it will eliminate the duplicate values, and I will mention this one as a T1. Okay, because it was mentioned as a T1, so I have written it. So T1 you got B, A1, A2. Now we will see the next one. Let me erase this one. T2 you have 5 with the attribute list S into T1, meaning is that S Cartesian product with the T1 temporary table, set difference with the relation R. So first let me apply the Cartesian product or cross product between the relation S and the relation T1. Okay, what is the relation S is consists of attribute A and value 1. What is the relation T1 is consists of B, A1, A2. Is it clear? Now I want to apply the Cartesian product between these two. If I apply the Cartesian product between these two, I will get it as attribute list as AB. Why I am getting the attribute list as AB? If you have m number of attributes in the relation S, n number of attributes in the relation T1. Attributes means even it can be called as a degree. If the degree of relation S is m and degree of the relation T1 is n, then the degree of S Cartesian product T1 will be m plus n. So meaning is that the attributes of A, S and the attributes of T1 should come here. So AB. And what about the tuples? Attributes is okay. Now 1 you have to combine means with A1 and also with A2. So you will get 1, A1, 1, A2, 2, A1, 2, A2. Is it clear? So these are the tuples you will get if you apply the Cartesian product between S and T1. Okay, let me erase this one. Then you need to apply the set difference with R. What are the attributes which are there in the R? A and B with the values 1 A1, 2 A1, 1 A2. Now they are asking you to apply the set difference. Remember one thing, whenever you need to apply the set difference or a set operators, any set operators like set union, set intersection, set difference, then you should check whether it is union compatible or not. The two relations should be union compatible, then only we can apply any set operator. What is meant by union compatible? Union compatible should satisfy the two conditions. One is that the degree of the two relations should be same. What is the degree of this one? Is 2. What is the degree of this relation? Is also 2. So the degree is matching. And what is the second point is that the corresponding attribute should be, domain of the corresponding attribute should be same. If you see, the domain of the attribute A is integers. Here also it is integers. So this one and this one is matching. They should match. Now B domain is characters. B's domain here also is characters. So it is corresponding. Meaning is that attribute 1 in this relation and the attribute 1 in this relation should be, the domain should be same. Similarly, attribute 2 in this relation, attribute 2 in this relation, the domain should be same. If you have third attribute here, here also the third attribute should be the same domain. That is what I want to say. In this one, it is satisfying the union compatibility property. Now we will discuss about the set difference operator. What is the set difference? What are the tuples which are present in this one and which are not present here? Those tuples we should bring it out as an output. Okay, let me repeat again. The set difference is that what are the tuples which are present but not present here? Those tuples only will come. 1A1 is there here also, so it will not come in the result. 1A2 is present here, it will also not come in the result. 2A1 is present, so it will not come in the result. Now 2A2 is present here but not here, so I can say that the output of this entire one will be 2A2. Okay, is it clear? Because this is the tuple which is present in the relation 1 but not in the relation 2, so you will get 2A2 is the output with attributes as A and B. Now you need to apply the projection operator consists of attribute B. How? We have discussed the attributes which are present in the relation R minus the attributes which are present in the relation S. So you will get B. So you need to apply the projection with B. So phi of B on this relation will give you the attribute B and the value as A2. So for this entire one, you will get the T2 as an output which consists of attribute B and A1. Now this is your T1 relation. So finally, what is the next third step? T is set difference between T1 and T2. So you have T1 consists of B, attribute B with values A1 and A2. T2 is another relation with having attribute B, value A2. Is it clear? So this is the relations which are there in the T1 and T2. Now we need to apply the set difference. So we need to check whether they are union compatible or not. They are union compatible because the degree is same and the corresponding domain is also same. So I can apply the set difference. If I apply the set difference, A2 attribute means A2 tuple is there in this one and also here, so it will not kill. But whereas in A1 is present here but not here, so the output you will get it as B with A1. So if you see that the output you got it as BA1, when we have performed directly we got it. So what I can say is that we have discussed how the division operator will come, output will come directly, and we have discussed internally what are the steps it will perform. We have discussed so that you will understand the division operator in a better way. Thank you so much.